Assalamu alaikum students. I hope you all are good. In today's video lecture, we are going to solve exercise 2.7. Let us recall the exponent rules first. Product rule. According to product rule, when the bases are same and the numbers are multiplying with each other, we will simply add the exponents. Next we have quotient rule. When the numbers are dividing with each other and they have the same base, then we write the base and then subtract the exponents. Next we have power rule. According to power rule, if we have exponent over an exponent, the exponents will be multiplied with each other. Next, power of a product rule. If we have a product and there is an exponent over them, then this exponent is applied with both the bases. Next, power of a fraction rule. When we have a fraction in a bracket and we have a whole exponent over it, then this whole exponent is applied on numerator and denominator separately. We do not apply this rule on addition and subtraction. Only on multiplication and division this rule can be applied. Next, zero exponent. According to zero exponent, if we have exponent 0 on any base, then the answer is equals to 1. Next, negative exponent. If we have a negative exponent, we can convert it into a positive exponent by simply reciprocating it. Fractional exponent. We can convert a fraction exponent into a radical form. The numerator of the fraction will become the exponent and denominator will become the index of the radical. Now start exercise 2.7. Simplify. Question number 1 is 8 exponent 1 upon 3 multiply 36 exponent 1 upon 2. We have to simplify it. To simplify it, we will first find the prime factors of 8 and 36. Factors of 8 will be 2 exponent 3 and the whole exponent 1 over 3 is there. Multiply 36. 36 factors of 36 will be 6 square, or you can write it as 2 square multiply 3 square. And the whole exponent of 1 upon 2 is written as it is. Now we will apply the law of exponent. When we have exponent over exponent, we will simply multiply the exponents. So exponents will be multiplied with each other. This 3 and this 3 will be cancelled out. This 2 and this 2 will be cancelled out. And we are left with only 2 exponent 1 multiply 6 exponent 1. Multiply both of them. We will get 12. To multiply 3 with 1 upon 3, we will follow these steps. This 3 and this 3 will be cancelled out and we will left with only 1. Second part, 64 exponent minus 1 upon 6. Here you can see that we have negative exponent here. So we have two options, either to convert it into positive exponent first, or find the factors of 64 first. You may follow any step. Okay, here we have find the factors of 64. Factors of 64 are 2 exponent 6. Again multiplying the power by applying the rule, we can multiply 6 with minus 1 upon 6. We will left with only 2 exponent minus 1. Now we will convert this negative exponent to positive exponent, which is equals to 1 upon 2. We have two options here, either to convert the negative exponent into positive exponent first and then apply the laws of exponent, or apply the laws of exponent first, simplify it, and then convert the negative exponent into positive exponent. You may follow any rule. Part 3. 256 upon x square having whole exponent of 1 upon 2. First of all, make the factors of 256. Factors of 256 will be 2 exponent 8. Now we have 2 exponent 8 upon x square and a whole exponent of 1 upon 2. Here we can apply the law of exponent, which according to the law, if we have a quotient and we have a whole exponent over it, then this whole exponent is written with numerator and denominator separately. So according to this law, we will have 2 exponent 8, whole exponent 1 upon 2, x square, whole exponent 1 upon 2. Again the law of exponent is applied here. The law which says when we have exponent over exponent, product of a exponent, we have an exponent over an exponent, we will simply multiply those exponents. So according to this law, this 8 and 2 will be 8 and 1 upon 2 will be multiplied, 2 and 8 will be cancelled out, and we will left with only 2 exponent 4 in the numerator. And in denominator, this square and this 2 will be cancelled out, we will have just x. 2 exponent 4 upon x. Now solve 2 exponent 4, it will be 16, and x is as it is in the denominator. Part 4. 81 x exponent minus 8, z exponent 4. Here again you have two options, either to convert the negative exponent into positive exponent first, or apply the rules of exponent first. Okay, here we are going to apply the rules first. First of all, find the factors of 81, which is equals to 3 exponent 4. This x exponent minus 8 and z exponent 4 is as it is in this step, and we have a whole exponent of 1 upon 4. Applying the law of exponent, we have a whole exponent. The whole exponent is applied with the bases. It means ab exponent x is equals ax multiply bx. So applying this rule here, we will have 3 exponent 4 having whole exponent 1 upon 4. X exponent minus 8 having whole exponent 1 upon 4. Z exponent 4 having whole exponent 1 upon 4. Again the law of exponent is applied here. This law can be applied here. So according to this law, these exponents will be multiplied with each other. When we multiply 4 with 1 upon 4, this 4 and 4 will be cancelled out, and we will left with only 3 exponent 1. Same happens here, same happens here. So we are left with 3 exponent 1 or just 3, x exponent minus 2, z exponent 1. Now in this step, we can convert this negative exponent into positive exponent by shifting this x exponent minus 2 in the denominator. So 3z upon x square is our final answer. Part 5. Again we have two options, either to convert the negative exponents into positive exponent first, then apply the rule, or apply the rule first, simplify it, and then convert the negative exponent into positive exponents. So here we have find out the factors first. Factors of 27 will be 3 cube. Exponent 2 n upon 3 is as it is. Factors of 8 are 2 exponent 3, 2 cube, and the exponent is as it is. And the factors of 18 are 2 multiplied 3 square, and exponent is as it is. Here we can apply two rules at a time. First rule, when we have exponent over exponent, we can apply this rule on these two terms. The second rule, when we have a whole exponent, we can apply this rule in the denominator. So applying the rules, We will have 3 exponent 2n in the, we are left with 3 exponent 2n in the numerator, because this 3 and this 3 will be cancelled out. Same happens here, this 3 and this 3 will be cancelled out, and we have 2 exponent minus n. Here applying the second rule, we have 2 exponent minus n upon 2, 3 square exponent minus n upon 2. Again we can apply the same rule here when we have exponent over exponent. So this 2 and this 2 will be cancelled out. We have 3 exponent 2n, 2 exponent minus n, 2 exponent minus n upon 2, 3 exponent minus n. Here we can see that in the numerator we have two terms having base 2 and 3. In denominator we also have two terms that have base 2 and 3. So we will shift all the terms from numerator to, we will shift all the terms from denominator to numerator, so that the same base terms can be solved together. Okay, so we are going to shift this 2 exponent minus n upon 2 and 3 exponent minus n into numerator. So the negative exponents will be converted into positive exponent. Now we have 3 exponent 2n, 2 exponent minus n, 2 exponent n upon 2, and 3 exponent n. These two terms which have negative exponent now have positive exponent. Here we can see that these two are the like terms because they have the same base, and these two are the like terms because they have same base. So when bases are same, we simply add the exponents. So applying this law, we will have 3 exponent 2n plus n, 2 exponent minus n plus n upon 2. Solving the exponents, we have 3 exponent 3n and 2 exponent minus n upon 2. Now we can convert this negative exponent into positive exponent by shifting it into the denominator. So our final answer is 3 exponent 3n upon 2 exponent n upon 2. To solve this minus n plus n upon 2, you have to take LCM. Okay, you have to make the denominator same first and then simplify. You have learned it in previous classes. Part 6. A exponent p upon a exponent q whole exponent minus q minus p. Multiply a exponent q upon a exponent r whole exponent minus r minus q. A exponent r upon a exponent p whole exponent minus p minus r. First of all, rewrite the question. Now we can apply the rule which says if we have same exponents and the numbers are dividing with each other, we will simply subtract their exponents. So applying this rule, we will have a exponent p minus q, and from whole exponent we can take negative sign common, so the whole exponent will become minus, and in bracket we have q plus p. Same thing happens here. Applying the rule inside the bracket, we will have a exponent q minus r, and minus sign is taken common from the whole exponent. So whole exponent is minus, in bracket we have r plus q, or we can write it as q plus r. And the same thing happens in the third bracket. Here we can apply this rule. When we have exponent over exponent, the exponents are multiplied together. So we have exponent over an exponent. So these exponents will be multiplied with each other. Same thing happens with this bracket. The exponents will be multiplied together, and with the third bracket, exponents will be multiplied together. So we have a exponent minus q plus p, p minus q, or we can write it as p plus q, p minus q. Okay, base a and the exponent is minus q plus r, or r plus q is same, so it's better to write q plus r. and in another bracket we have q minus r. Third bracket we have a exponent minus r plus p, r minus p. Here we can see that a formula can be applied here. The formula which says a minus b bracket a plus b is equals to a square minus b square. We can apply this formula on the exponents. Okay, according to formula this will become a exponent minus, and in bracket we have p square minus q square, not q square minus p square. We put squares according to the bracket that have negative signs. So when we apply formula here it will become a exponent minus p square minus q square. Okay, when this minus sign will be multiplied with p square minus q square, it will become minus p square plus q square. This thing, same thing happens with this bracket and with this bracket. When applying formula it will become q square minus r square, and when multiplying it with negative sign we will get minus q square plus r square. Okay, here when applying formula it will become r square minus p square. When multiplying with negative sign it will become minus r square plus p square. We have same base, so we will simply add the exponents. Write the base ones and add the exponent. Here we can see this minus p square and plus p square can be cancelled out. Minus q square and plus q square, they both can be cancelled out. Same happens with these r square. So we are left with only a exponent 0. And we have learned that when we have negative exponent or we have 0 exponent, when we have 0 exponent it is equal to 1. So answer is just 1. Moving to part 7. Rewrite the question first. Okay, here we have fourth root of ax upon ay, fourth root ay upon az, multiply fourth root az upon ax. Here we can apply the same rule. We have quotient, so we can write the base ones and the exponents will be subtracted. So we will apply this rule inside the radical sign. So we will have fourth root a exponent x minus y, fourth root a exponent y minus z, fourth root a exponent z minus x. Okay, this fourth root can be written as a fractional power 1 upon 4. Fourth root, this is a radical exponent, we can write it as a rational exponent as 1 upon 4. And same thing happens with the third bracket. Again we have exponent over an exponent, so we will apply this rule here. Multiply the exponent. When we multiply this 1 upon 4 with x minus y, we will get x upon 4 minus y upon 4. Same happens here. When multiplying y minus z with 1 upon 4, we will have y upon z multiply z upon 4. And same happens with the third bracket. Again we can see that we have same base and the numbers are multiplying with each other. So we can write the base ones and all the exponents will be added together. Okay, we can see that this x upon 4 and this minus x upon 4 can be cancelled out. This minus y upon 4 plus y upon 4 cancel out. Minus z upon 4 plus z upon 4 can be cancelled out. So we are left with a exponent 0. And whenever we have 0 exponent, the answer is equals to 1. So 1 is our answer. Part 8. It is exactly same as question number 6. Rewrite the question, applying the rule. Inside the bracket, it will become x exponent L minus m, x exponent m minus n, x exponent n minus L. Again we have exponent over exponent, so the exponents will be multiplied together. Okay, applying this rule, we will multiply the exponents together. Here we can see, instead of multiplying both the brackets, we can apply a formula here. The formula which says a plus b, a minus b is equals a square minus b square. So applying the formula, this formula we are going to apply here. When applying the formula, it will become x exponent l square minus m square, x exponent m square minus n square, x exponent n square minus l square. Bases are same, we will add the exponent. When adding the exponent, we are left with only x exponent 0. All the exponents will be cancelled with their like terms. Okay, whenever we have 0 exponent, the answer is just 1. Question number 8 was exactly same as question number 6. Question number 9. It is also same as the previous questions. Okay, rewrite the question. Again, we can apply the rule inside the bracket. So we will apply this rule. We will write p exponent a minus b, p exponent b minus c, p exponent c minus a. Whole exponent is written as it is. We have exponent over an exponent, so we are going to multiply both the exponent. According to the law, it will be p exponent a minus b bracket a plus b minus c. Okay, both the exponents will be multiplied with each other. Here you can see that we cannot apply that formula, so we will multiply these brackets. To multiply these two brackets, we will take this a first and multiply the second bracket with it, and then take the second term of the first bracket and multiply the second bracket with it. Same happens with these two brackets and with these two brackets. When multiplying these two brackets, we will have these terms. When multiplying a with this bracket, we will have a square plus ab minus ac. Then multiply this minus b with the second bracket, we will have minus ba minus b square plus bc. Same thing happens here and same thing happens here. Again, we can see that we have same base and the numbers are multiplying with each other. Okay, so we will write the base ones and add all the exponent. Like terms will be cancelled out with their like terms. This a square, this minus a square cancel out, plus ab minus ab, ba and ab both are same, cancel out, minus ac plus ac cancel out, minus b square plus b square cancel out, minus bc, sorry, plus bc minus cb cancel out. In the same way, all the terms will be cancelled out with their like terms. We are left with only, okay, not this step, we are left with only p exponent 0. And we know that whenever we have 0 exponent, the answer is equals to 1. Okay, this step is not here. We are left with only p exponent 0, and we know that whenever we have 0 exponent, the answer is equals to 1. Question number 10. 125 square multiply 8 upon 64 square and the whole exponent is 1 upon 3. Okay, we have to simplify it. To simplify it, we will find the factors first. Factors of 125 are 5 cube whole square as it is. Factors of 8 are 2 cube. Factors of 64 are 2 exponent 6. And we have a whole exponent of 1 upon 3. First of all, simplify the terms within the bracket. Okay, we can apply the rule here. Exponent over exponent, exponents will be multiplied. Same rule will be applied in the denominator as well. So according to rule, it will become 5 exponent 6 because 3 and 2 will be multiplied with each other. 3 2s are 6. 2 exponent 3 as it is. 2 exponent 12. Now we can apply this whole exponent. Whenever we have a whole exponent, the exponents can be applied on the numerator and denominator both, all the terms. Okay, So it will be 5 exponent 6 having whole exponent 1 upon 3. 2 exponent cube having whole exponent 1 upon 3. 2 exponent 12 having whole exponent 1 upon 3. Whenever we have exponent over an exponent, we can apply this rule. According to this rule, this 3 and 6 can be cancelled out and we will left with only 5 exponent 2. Here 3 and 3 will be cancelled out and we have left with 2 exponent 1. Here we are left with 2 exponent 4. Okay, here we can see that we have 2 exponent 1 here and 2 exponent 4 here. So they can be reduced, or we can say that we will apply the law of exponent. Bases are same and the numbers are dividing with each other. We will subtract the exponent. So 2 exponent 4 minus 1 will become 2 exponent 3. 5 square is 25. 2 cube is 8. This will be the answer, or you can convert it into improper fraction. 11. Again the question is to simplify. To simplify it, we will find the factors first. Factors of 4 will be 2 square. Factors of 15 will be 3 multiply 5. Factors of 9 are 3 square. Factors of 10 are 2 multiply 5 and the factors of 25 are 5 square. Okay, here we can apply two rules at a time. These two rules can be applied at a time. The first rule, exponent over an exponent, can be applied on this term and this term. And this rule can be applied on these two terms. So applying the rules, we have 2 exponent 2m, 3 exponent 4m minus 2n plus 1 and 5 exponent 4m minus 2n plus 1. This whole exponent is applied on this 3 and 5 both. Here we have 3 exponent 2n minus 4m. This 2 is multiplied with 2n minus 2m. So we have 3 exponent 2n minus 4m. Here we have 2 exponent 2m and multiply 5 exponent 2m. And this square is multiplied with m minus n. We have 5 exponent 2m minus 2n. Here we can see that this 2 exponent 2m and 2 exponent 2m can be cancelled out. Okay, they both are same, exactly same with same base and same exponent. So 2 exponent 2m and 2 exponent 2m can be cancelled out from numerator and denominator. We are left with 3 exponent 4m minus 2n plus 1. This term 5 exponent 4m minus 2n plus 1, 3 exponent 2n minus 4m, 5 exponent 2m, 5 exponent 2m minus 2m. Okay, here we can shift all the terms from denominator into numerator so that the like terms can be solved together. So when shifting these two terms from numerator into denominator, it will become, it is 5 exponent 2m, it will become 5 exponent minus 2m. This is 5 exponent 2m minus 2n. It is now 5 exponent minus 2m plus 2n. Okay, here we can see that we have these two like terms because they have same base, and these three are the like terms, they have same base. So when bases are same, we simply add the exponents. Applying the rule, 3 is written once and all the exponents are added with each other. Same happens here. This 4m minus 4n can be cancelled out. Minus 2n plus 2m minus 2n plus 2n can be cancelled out. Here plus 4m and these minus 2m can be cancelled out. Minus 2n plus 2n can be cancelled out. So we are left with only 3 exponent 1 and 5 exponent 1. 3 exponent 1 is 3 and 5 exponent 1 is 5. So multiplying 3 and 5, 15 is your answer. Question number 12. We have to simplify again. 216 exponent 2 upon 3, 25 exponent 1 upon 2, 1 upon 25 exponent minus 3 upon 2, and whole square is written over them. So find the factors first. These are the factors. This negative exponent can be converted into positive exponent. So we have reciprocal it, and the negative exponent is now become positive exponent. Applying the rule, whole exponent can be applied to every term separately. It has become 2 cube whole exponent 2 upon 3, 3 cube whole exponent 2 upon 3. It is same 5 square exponent 1 upon 2, and 25 is equals to 5 square exponent 3 upon 2. Now we have exponent over exponent, so we will multiply that rule. This 3 and this 3 will be cancelled out. Same happens here. The exponents 3 and 3 will be cancelled out. 2 and 2 will be cancelled out. And this 2 and 2 will be cancelled out. We are left with only 2 square. Multiply 3 square. Multiply 5 upon 5 cube. This 5 exponent 1 from numerator, 5 exponent 3 from denominator will be solved together, and we are left with only 2 square multiply 3 square multiply 5 square. Now we will apply this square root over them. The square root means we have whole exponent 1 upon 2. Whole exponent 1 upon 2 will be applied on numerator and denominator both. So this is 2 square exponent 1 upon 2, 3 square exponent 1 upon 2, 5 square exponent 1 upon 2. Again the law of exponent will be applied here. This 2 and 2 will be cancelled out. Same happens here, same happens here. We are left with only 2 multiply 3 multiply 5. Multiplying them 6 upon 5, converting into improper fraction. So 1 whole 1 upon 5 is your answer. Part 13. First of all, we will find the factors. These are the factors. Second step, applying the rules. Applying the law of exponent. Whole exponent is applied on a 2 square and 3. Okay, same happens here and same happens here. Now we have exponent over exponent. We will multiply those exponent. This 2 and 2 will be cancelled out. Here this 3 and 3 will be cancelled out. And here this 3 and 3 will be cancelled out, and this 4 and 4 will be cancelled out. We are left with these terms. Here we can see that this 3 and this 3 can be cancelled out, and this 5 exponent 1 upon 2, 5 exponent 1 upon 2 can be cancelled out. We are left with only these terms. Okay, here we can see that we have some terms having 2 as the base, and we have some terms which have 3 as the base. So shifting all the terms from denominator into numerator. Okay, instead of shifting it, we will first simplify the like terms of numerator and the like terms of denominator. We will first simplify them and then shift them from numerator to denominator, or from denominator to numerator. So solving this 2 exponent 1 upon 3 and this 2 exponent 1. Okay, 2 exponent 1 upon 3 plus 1, and in the denominator we have 2 exponent 1 upon 2 minus 2 upon 3 plus 1 upon 2. Okay, solving these fractions, we will get 2 exponent 4 upon 3, 2 exponent 1 upon 3, this 3 exponent half, and this 3 is written as it is. Now we will convert these two terms from denominator to numerator, and their exponents will become negative. Okay, this 2 exponent 1 upon 3 is shifted to the numerator, and it will become 2 exponent minus 1 upon 3. Instead of shifting this 3 exponent 1, we can shift this 3 exponent 1 upon 2 from numerator to denominator. It will become minus 1 upon 2. It is minus 1 upon 2. Okay, now solving the same base, exponents will be added. So 2 exponent 4 upon 3 minus 1 upon 3. Here we have 3 exponent 1 minus 1 upon 2. Solving the fractions, we will get 2 upon 3 exponent 1 upon 2. We cannot solve it further, so this is our answer. Instead of writing 3 exponent 1 upon 2, we can write it as square root of 3. This is the answer. Question number 14. Here we have 4 exponent 3 square. The exponent of 4 is 3 square. It is not like this. There is a difference. Okay, there is a difference between 4 cube having whole exponent 2 and having 4 exponent 3 square. They both are different. Okay, when solving this, the exponents will be multiplied with each other because the law of exponent is applied here. We have exponent over an exponent, so it will become 4 and 3 twos are 6. When solving it, it is not exponent over an exponent. The exponent is 3 square, and we know that 3 square is equals to 9. Okay, so when solving 4 cube exponent 2, it will be 4 exponent 6. When solving 4 exponent 3 square, it will be 4 exponent 9. Okay, come back to the question. Here we have 4 exponent 3 square divided 4 exponent 2 cube. Okay, it will become 4 exponent 9 because 3 square is 9 divided 4 exponent 8 because 2 cube is 8. 4 exponent 9 upon 4 exponent 8. Here we can apply the rule. When we have a quotient and same base, exponents can be subtracted. So 4 exponent 9 minus 8, it is 4 exponent 1, which is the answer. That's it. Our exercise 2.7 is completed. That's it for today. Thank you.